Hey all, thought I'd just give a bit of an overview of the Land Rover 110 I'm building, custom 110 or K110 as I call it. Started out life as a 1998 300 TDI 110 cab chassis. So in Australia we got them as just a two-door cab with no bodywork on the rear, and they were fitted with the what we just call an alloy tray, flatbed tray with sides that fold up and down. We didn't get the pickups here, which are the bodied utes or two-door cab, truck cab with the ute tub. We did get some high caps towards the end with the last of the Defenders, and we got a few hard tops, but mostly the vast majority of Defenders sold in Australia were 110 wagons, 110 cab chassis or utes, 130 double cabs with the tub or without, and 130 cab chassis, again just two doors like this but longer bed obviously. So like I said, 98 model 110. I modified it over the years with a few things, but mostly just bolt-on stuff, and got a bit of rust in the firewall and a bulkhead and various other things, and always wanted to do a lot of modifications to it. So decided to, a few years ago when I retired it as a daily driver work vehicle, to put it under the knife, and here we are. So I'll probably start at the back here. I've shortened the rear chassis by about 200mm or 8 inches, and it puts the rear overhang sort of halfway between that of a 90 and a 110, so longer than a 90 but shorter than 110. Formed up and made my own rear cross member, that's 5mm, and crushed, like I put the jacking points for sort of tradition, give the traditional look, and then all the fixture points on the rear got solid heavy duty wall crush tubes we've got 4 bolt holes for pin tool, and then clevis pins for safety chains, and then I've made up some recovery points that'll bolt on either side. The chassis wise, I just cut the original chassis off, and it actually cuts off down here, and I 45 degreed it and radius the corners. I cut it off about its lowest point of curve. The reason I just didn't go straight, which is structurally good for load path, is I like the fact that the swooping down chassis protects the fuel cell or fuel tank. I'm still going to put a fuel tank in there. Obviously it's a lot smaller, it'll hopefully hold about 50 litres when I fabricate that. So the old chassis rail inside these doublers which I've made, or chassis rail extensions that are welded right into the C of this cross member before it was boxed in. That you can see the old probably outlines of the weld from the inside on the end of the chassis rail to this, and then we've got a nice transition. The reason I did that was, you could just butt join it and structurally that would be pretty sound. What I like is a smooth transition and not an abrupt transition of stiffness. So where we've just got 2mm wall original factory box section, and then we overlap it, and pretty much all the stuff I work with is 3mm. It's going to go from a certain amount of stiffness to more stiffness, and I don't think it's great to just change that abruptly in a straight line. So we go for and this is pretty stiff in this section area because we've got the intermediate cross member here above the rear axle. So we've got stiffness through there, and then come into this midsection, and it transitions into stiffness through here, and then it transitions out of stiffness where the old chassis ends, because obviously it kept going down or swooping this way and was inappropriate to go any further. And that's the reason I've done, well, because of the shape and the load path is more aggressive now, being shorter. I made these chassis, what I call chassis ties, for the load path of towing and recovering and stuff like that, plus they act as load-bearing members for the rear tub, and that's why we've got these little supports here to transfer our vertical loads from the webs into the webs, and we've just got good connection of these chassis ties into the top of the original chassis rail and back down and around the back of the rear cross member there. So they were formed up out of a plate first that was welded in, and then I folded a C-section and then welded all this corner, and obviously welded all those in. So like I say, chassis been reduced in length by 200 mil. The factory coil mounts still where they were, haven't modified those. In extreme cases, there can be some issues with these. I don't think this will be the case with me. I might do some small reinforcing, but we've got some with the new dampener mounts, which obviously are pretty extreme compared to the Land Rover ones that was bolted in these 3 holes. But I'm running Bilstein 9100 12-inch travel remote reservoirs, and being a true racing shock, they're not efficient in length, as it were. So their collapse length is 500 mil, I think, fully collapsed. So, and the custom rear axle, Rover housing, but I've customised it all. So the mounts are actually on top of the trailing arms because of packaging reasons. So that's just an issue of why they're high. Yes, they're going to come up into the tub, but that's life. So one of the things that was the sort of the main ethos behind this build was suspension geometry was paramount, and I'm not chasing crazy articulation. I will have better articulation than factory, but the performance of the suspension, and not only off-road but on-road, this is going to be an all-round touring vehicle. It's going to see road miles, plenty of them, at road speeds, at highway speeds. Safety and handling are paramount, and the goal is to have a vehicle that performs as well, if not better, than a factory vehicle. And what I mean by that, this is going to have nearly a 2-inch spring lift, and obviously that raises the centre of gravity, and it changes things, and it changes them quite rapidly when you get down to it. But I want this vehicle to hopefully perform every bit as good, if not better, than factory. So with regards to that, the rear trailing arm mounts are much further forward. They're about 300 mil longer than standard, and so I've got the factory mounts, cut the old ones off, bin them, got factory mounts, and then relocated them in a new spot. This is some extra stiffening I've pulled over them, because there's been the odd case with the heavy duty vehicles where they crack from the corner of the chassis rail into this hole. So we've added a 3mm overlay with a fold back here all the way around there to try and help reduce that. I mean, a tie from this corner would be good, but it gets a bit in the way there. So, and anything that I've changed, cut off, and then added in a new location, like new body outriggers, what I've done, because we don't know, like what Land Rover do with their chassis is they're tall and thin box section. They're only 2mm thickness material, 2.2 maybe. They have formed angle that's spot welded on the internal corners. So up on this corner, top flange web, down here on all 4 corners at strategic locations throughout, there's lengths of at least 3mm. I've only been able to eyeball it, 3 to 4mm thick angle that's formed up, and it's spot welded in there. They also have, like, obviously where your bolt holes are, they've got little sort of pseudo crush tubes, but they have these little spreaders here throughout the chassis, again at load points. So we don't know, without cutting it up for certain, what is in the chassis at where I've changed the mounting points. So using 3mm plate, that would be a maximum thickness you would want to use. I've formed what I call a chassis doubler. So these are folded up as a C. The top flange welds to the centre line where the original weld is, down the centre line of the clamshell chassis rail. And again, we fish mouth them for smooth transition with radiuses. This doubler goes from there through into behind here. Okay, and that picks up the rear trailing arm mount and the new rear body outrigger. And that's to stiffen and strengthen the chassis at a point where we don't know that there might not be that additional strength, because the old trailing arm was here and the body outrigger was there, and the same with my modified radius arm mounts. So that's just a way to ensure that we're not loading the chassis in a point where it wasn't capable of handling that, what now is a new load at that point. Again, I like to use the factory mounts because they're proven, they work. A lot of guys would change to eye. I like these mounts. You've got the eye at the axle end, and then you've got a pin at this end. the axle is twisting this way, the pin can rotate this way, so we get zero bush bind. I know that a lot of people have problems with the bind on the stock arms, especially with lifted vehicles, because the angles are all wrong. The longer arms and this set to my new angle, it's not an issue. I use Super Pro bushes at the chassis on the radius arm and the trailing arm. I use factory, well, what's in this case, Nissan bushes at the axles, and I'll go into that a bit as well. So we've got the rubber and compliance there, and a little bit better dampening for harsh vibrations and stuff on the rubber, whereas the polyurethane's got a really good durometer for flexibility. They are a touch harsher. I'd only ever run Super Pro. Very good experience with them for a long time, and they're not just the old hard no-lethane or urethane, and there's a lot of misconceptions about polyurethane, and people rubbish them or shit can them because they had a bad experience, or some mate they know had a bad experience with some really hard ones from companies that are used to making them for street vehicles and whatnot. So again, where the dampener mount ties into the web, where it's crucial to transfer that vertical load or force into the web of the chassis, I've put a doubler that goes up there and up there. It folds over the top and wraps into there, and it folds under and wraps into the center line. And again, that's we're adding a load to a point we don't know, so we're stiffening that up. This angle here that's been formed through here, this was where the old A-frame cross member, so there's my new one. The old A-frame cross member was in here, and where the end plate came down and capped over the chassis rail, there was crevice corrosion. You can probably see a little bit of residue on the inside here. So that would have been it there. That's not too bad at all. It was worse on the outsides. They're an absolute trap for water, the way Land Rover, or moisture, the way Land Rover did them. And because they're only partially welded, they were welded down here all the way along here and back up again. But on the inside, especially with this radius leading into this plate, moisture gets in, it seeps in there. Terrible crevice corrosion. And you can't see it. You can't treat it. You can't see it. I had a couple of pinholes and some, acne scar, if you want to call it, through there. I cleaned it all up, wire wheeled it right back to completely bare and good. And then with everything that's overlapped, the chassis and the piece of material, whether it's the doubler or the angle or whatnot, gets treated with zinc-rich paint, or cold gal, if you want to call it, in a spray can. I have to keep it back about 7 mil from the weld lines because it bleeds in and contaminates the welds if I don't. But that's got multiple coats, and like here's the section I'm doing here now. Sorry for the terrible recording, I'm just holding a phone in my hand. So I've got a little plate, and I should have that here, a little doubler plate, because at the back of these dampener mounts, we transition at this height here. It's a bit hard to see. I might just peel this off. The big reveal. It's a boy. Oh, well, no OnlyFans for you, champ. Alright, so this little brace at the back, which goes all the way up and down, because we need to get this load into the web. And we couldn't just bring this back over here because it would foul on the load line of the tub and create a lot more problems. So brought it in and finished it down the seam of the weld. Again, we're welding on top of a weld where there is already a stress contained. We're not, you've got to be a bit thoughtful about where you're adding stresses. Yes, I've added a lot of welding, but with as best thought and approach as I can. So to to form this piece over this was hard because it's curved. And there was an original factory load bearing point here that I needed to leave at the time, and I was potentially going to use. Don't need to use it now, that's changed, so I need to continue the same as this to transfer this load into this down into the web. So I formed up this, and again, see that's all taped off, zinc paint, taped off. The black lines will be where the welds are. That'll sit in there nicely and weld over. And again, 45-degree ends with a radius on the corner to blend in, so we don't have abrupt welds across the direction where we can create potential stress rises that will create cracking. So we'll propagate, where cracks will start. So that's something in the pipes to do there. And on that one as well. The A-frame crossmember, so we talked about the longer trailing arms. I also lengthened or made new trailing arms completely from scratch, made new radius or A-frame arms from scratch and a new cross member. The square or rectangle box section cross members were originally in the Range Rover Classics because they had the Boge load leveler, Sachs Boge hydrostrut. For when you increase the load on the vehicle, they could maintain a relatively soft spring, and it took for the sag in the spring because you've added load to the cargo area. The Hydromat was it was completely mechanical, like a massive shock absorber that worked a little bit differently. And when you took off, when you drove off, the acceleration reaction forces at the axle housing, which is torque rotation, made it work. Basically, it reacted to that reaction and it pumped up. So when you load your Rangy up, they'd sit down, they'd sag, and people think, oh God. But then when you drove off, they came up to level. Really good idea. Central pivot point didn't limit articulation at all. They worked brilliantly for what they were. And, so that rectangle cross member there was the reason it was that shape, because you had to bolt that Boge strut load leveler to that cross member. So I'm not using that anymore. It wouldn't work with my application. It'd be on a really weird angle. Something like this, a tube cross member, is ideal, and they did that on the Discovery ones. So I spec'd it off the Discovery One size. It's a little bit, tiny bit bigger in diameter and probably 1 mil thicker in wall thickness. I used the Land Rover design for end capping and transferring down into the chassis rail. Again, really good concepts and engineering. They did a lot of things right, especially with working with their tall and thin chassis. The end caps are also the link mounts in my case, or one half or one side of each mount. And the end caps also go, sorry, that's terrible, under and in and weld up to the chassis web there, as per Land Rover did. So, again, I've probably upped the thicknesses a little bit. Like this is 4 mil here, and then I took this outside because we don't just want 4 mil for bolt load bearing. That's 6 mil, and I took it past the bend, so we didn't get flex at the bend because there's clearly a bend in that from straight on the chassis and then out on the angle that we need for the A-frame arms, and then took it past. Doesn't go all the way back, but it goes past this point here, so we get that rigidity from here, and we tie it into here, and then this is just our flat 6 mil there. So 4 and 6, and 6 and 4, I think, or 6 and 5. These are just to give more load capacity for the bolts, basically. So the concept of the longer trailing arms, it does a couple of things. In this case, it reduces anti-squat, which for four-wheel driving is pretty important. And it also reduces axle roll axis or roll steer. So the anti-squat, anything anti is a jacking force. So anti-squat, anti-lift, anti-dive. So anti-squat and anti-lift are acceleration forces or reactions to, and anti-dive is a reaction to braking. Anything anti is a jacking force. So what we mean by that is when you've got the trailing arm coming from the chassis down to the wheel, because it's jacking, part of the force is pushing the chassis up. It's not all flowing forward and pushing the vehicle forward. We just want to push the vehicle forward. Sure, you don't want to have your anti-squat so low that when you take off at the lights, the rear of the car squats right down, But they're constant forward drive. I'm keeping it constant forward drive. We've only got half the torque to the rear. There's some thought process to that, but definitely lower than factory. And the other thing is when we lift the vehicle, when we add larger tyres, when we lift the vehicle, it really sends the anti-squat climbing. And I'm talking statics, at ground level, and then that gets worse through droop. So the A-frame arms being longer were to create a good combination with that anti-squat, because the top arms in relation to the bottom arms determine the anti-squat. So it's important where they mount and how high and whatnot. But it also is to do with the pinion angle. So as we go up and down through our movement from ride height to full bump to full droop, the pinion changes. It's got to. They're not parallel arms and they're not the same length. And we want that to not be excessive. So plotting those out was good or crucial to get that as small as possible, so we're not binding up the uni joints. And we're just getting that nice transitional flow to the front of the chassis pushing forward. So that's why the A-frame cross member's there now, because it's a relationship to the lowers. I didn't want the uppers to be really short. There's plenty of long arm kits out there. They are most of them are an improvement, and it's okay to run them with the factory uppers. It's not the end of the world. You'll definitely see the improvements, but I just wanted to, I'm doing all this work, so hey, in for a penny, in for a pound, so to speak. So that was the reasoning behind those. And with the long trailing arms, and because of my packaging issue, those are my dampener mounts to fit the really long. I mean, they're only 12-inch travel, but they're just a long packaged shock. Big cylinder, 60mm piston internal size, 22mm diameter shaft. They're really nice shocks. So this was the sort of mount. And this mount, actually, I'll give credit to a mob in America called Kibitech. They build mostly pre-runners, which are sort of luxury trophy trucks designed for pre-running the courses. They build, a lot of kits and stuff, but from ground up they build them. Some are tube frame and some are just modified factory vehicles. Amazing, high level work. And they've actually got one Defender 90 they're building, and they do coilovers, and this mount is based similarly. They tied theirs in a little bit differently and whatnot, but this basic design is based off what they did for their coilovers. I really liked it for what it achieved structurally, and aesthetically it's quite nice. So there's had a different web in here, and I did the dimples and stuff, but being able to tie it into the spring perch was good for me. Theirs obviously doesn't, because they do away with all that, but I've got to give them credit for their work and their basic design. You'll see that this light's terrible, sorry guys. This here, which is where the remote reservoir fitting and hose comes out, they come up with all that sort of, I can't take much credit other than adapting it to my situation and picking what needed me, and then deleting a couple of things that didn't. So definitely check out them. They're on Instagram, Kibitech. They've got some YouTube as well. Just unreal top level work. Really good stuff. So that's the rear. We've got rear cross member about 200mm shorter. These are just the start of the load bearing points for the tub. So all the cross members that are fixed to the underside of the tub, and there'll be 6 in here. There'd be 6 on a full set, but I've got 6, so I'm going to use them and just put the spacings a bit closer to hopefully stiffen the whole thing up. But you'll notice that I just haven't sat them on here, which they did in the later vehicles, but from the series onwards, Land Rover put the load path, so where they formed, and they're stamped and press formed this odd shape cross members that sit across here, because you've got your flat floor, you've got formed top hat stiffeners which run lengthways and are spot welded to the bottom of their aluminium, and the spot welded to the aluminium floor. This cross member, which again is mounted to the tub, comes across and then down and flows over each stiffener and touches the tub in between or intermediately. They're steel and galvanised. They've got a reinforcing in their section, and it's here. It's not on the chassis, it's inside. And the reason Land Rover have done that is they put all their load-bearing points down the inside of the chassis rail, because it's a vertical load. I'm pretty sure they want to tie that vertical load into the web, the side of the chassis rail, not the top flange or the bottom flange, but the sides. And so it's easiest to make their mounts, these, all the way down the inside of the chassis rail, so therefore that's where their load points are. So I just formed up these little outriggers, I guess you call them, little flange there, and end cap, and little drain hole and whatnot. And those ones will be, the tops of them will look the same, but obviously each one will be different. I only had 45mm here to work with in height, and then there I've got the chassis to work with, so the tops will all be very similar, and then the sides will be a bit different depending on each location, height, and what they need to be. So down this end we'll have to do something a little bit different, because where they would be here and here, they will, I've got an issue with mounting them here and all this. So if you've ever seen the rear of a TDI 110 where this part is, and it's not tied into the chassis or the cross member, it's just a load point, a vertical load point. I'm going to do something similar to that for these last two. So that'll work quite well, and we'll get our loads into the webs, when especially where I've got these stiffer parts here. So I was going to put my battery trays one either side. Unfortunately, the batteries on what that I'd like to run size-wise, which are just the N70s. Even with the battery down here, back here, it's going to foul the floor. So and the cross members and stuff, the tub cross members. I can't see any way around that, unfortunately. And barely fitting them in, not really fitting them in. But then how would you get them in and out, especially with a tray's got to have flange or webs on the side? And yeah, so that's not going to happen. I think they're going to go back to under the passenger seat, but that's not the end of the world. These rear tub bulkhead mounts normally bolted on. I think they might have been welded on the original series vehicles, but the Defender ones, they're bolted on. They're really flimsy. Not a fan of them. They just, they do things for good reason, but they also do things for economic reasons. Like, it gives them more adjustment. So they have slotted holes here, because this was an original outrigger that I modified. Slotted holes so they can move this way, slotted holes on the bracket so they can move that way, slotted holes everywhere, and they're just really flimsy. So we went back to making something a little bit more substantial. This is 4mm here, and I've got slotted vertical holes. I felt I didn't need the front and back adjustment, because I'm building the thing. So it's not just pumped out of a factory. Hopefully my tolerances are holding a little bit tighter than the factory, and I've got it square off a chassis center line, and everything's being built square to that. Fortunately, the original front bulkhead outriggers are pretty good. They're within a mil or two for, no more than, I think it's 1.5 mil out of square, so to speak, from the center line over the full width, which is pretty good for Land Rover. And height-wise, I was able to go from a 1/2-inch bolt to a 14 and offset the holes a little bit, and that got my height-wise for level within a mil and a half when the chassis is level across it. So that was pretty good as well. So they're all welded in and gusseted, more substantial, bit better strength there for tying in to the tub at that point, because the tub really is only bolted there and at the rear cross member. The rest is load bearing points. They're not bolted. There's literally rubber riveted to the tub cross members that sit on all those load points. We are transferring load, but we're allowing torsion and vibration and all those things to happen without it being fixed and causing fatigue, vibration fatigue and cracking and aluminium tub and in the chassis. So again, really good, simple, basic engineering that Land Rover did, but it's good. Their chassis, other than rust, their chassis were well designed for what they were, and they definitely did the job well in my opinion. So factory cross members still here. Haven't done much different to that really. It's the same. Bump stops are still factory, and that's that point. As far as the cab goes, I've lengthened the cab by about 200 mil, and that's why the outrigger versus the trailing arm mount have sort of swapped positions to a degree. So I'm actually going to make longer doors. A lot of the extra cabs, they're just a standard door and then an infill. Well, they've got this point still here, and then they're doing. I want the cab to be a true longer cab. I want the seat base to be back further. I'm 6'1". I like my leg room, which Land Rovers and leg room, there's just they don't exist together. The Land Rover seats are really good. I think they're fine. The Defender seats are really good position. I like quite an upright seat. They're enough support, and they do what they need to do quite nicely if they're in good nick. If they're 30 years old and flogged out, well, obviously any seat's going to be a bit of uncomfortable if all this foam's gone and whatnot. So everything's, the front bulkhead is factory. As in where it's located, the mounts, that's all factory. The rear is just moving rear. So move that back. I've got a 130 double cab roof, which is 2 parts factory, and I'll pull them apart and cut and shorten and refabricate it to be the right length. And I'm building a tub, so this is essentially going to be a 110 pickup. So it's going to be tub size, tailgate, pickup cab, 2-door cab, not a hard top, not a full length top. Eventually it might be, but this is what it's going to be at this stage. So that's the idea of that, and so this is one of my original cab chassis bulkheads. That's how they came. The side panel actually just went straight down, but this is what we got in Australia. And then the tray came up to here, sort of thing, on the mounts and whatnot. So I picked the skin off that, and I've got new sides to go on, and I've got to build the whole tub from scratch, because nothing exists, and you can't buy 2-door tub sides here in Australia. They're just rarer than rocking horse, and I got hold of some new ones out of the UK, so which was a mission. But anyway, this structural steel mounting bracket, the one that you have on a cab chassis, is completely different to a pickup, and hardtop, which is different again to a wagon. So that didn't exist, and I'm just going to make my own. There's that mob in the UK, I think it's YRM or YMR metal, that make a hell of a good range of stuff. I basically just picked through their website to see the differences and see how Land Rover went about it, and then maybe add a few things or changes a few things, but use Land Rover's way as a starting point. I've got this flange here folded, and obviously I couldn't fold it in that shape. I don't have, a 10,000 pound press to stamp these things out, so I'll weld a flange in under there that'll come down onto this and stiffen that all up, because this is way more structural than the aluminium. This will end up getting galvanised, hot dip galvanised, so I've added a few bolts to tie it together. And then this is needed because our seatbelt mounts mount through the aluminium into this, and then also our rear cab stays. There's stays that go, diagonal stays that stiffen this up as well, that go in there. So this steel is crucial, and it'll have some gussets in here again, as per Land Rover. That they did some stupid stuff, but they did some good stuff as well. So and with these sill rails, I guess you'd call them, I just took the factory rail, and the reason why I didn't just make something from scratch was I still had the factory ones, and I'm doing so much work here. If I can make something a little bit simpler without it being too much of a compromise, I'll do it. They have the ends, and I've just got another one here that I'm going to grab. They've got the formed ends, which mount up to the bulkhead, that's stepped and slotted and everything, and trying to do all that. And then this indent here where the seat base meets, and I just didn't really want to go through all trying to fabricate that, so I just literally cut the original one, not in half, but in a location. You can probably see there's a weld there and there. That's my extension piece, so I got that folded in the same. Land Rover just had it as a C section. I didn't like that, especially with the length that I now had. So I got some flat plate and put some dimpled eye holes or flared holes. So the flared holes are two things: to allow drainage, because we've now boxed it in, and all of those holes line up with the mounting holes for the floor and the seat base. So I've got access with a socket through every single one, and this end has been profiled like such because you need to be able to get in there to do the bulkhead bolts. So that allows us access for that. So that just stiffens and strengthens that up, and creates the length that I need. So regarding the doors, at this stage I'm going to build series style doors, longer. There's a guy in Australia that sort of part-time makes new door skins, and the last time I spoke to him, which was a little while ago, because nothing goes quick with me, he's happy to make longer door skins. So, and he's got the tools to form them and form the nice flare or flanged hole for the lock. So I've got 2 left and 2 right, series 3, I think 203 doors in really good nick. The frames, very, very, very little rust in them. I'll pick the skins off them, I'll cut and shunt and weld them all together, and put some more bracing in the door and side impact intrusion protection. and go from there. The tops, obviously, I'll fabricate as well. Still a sliding window. I've got some ideas there. I'm hoping to get some Parenti tops. They are much stiffer. They're all complete aluminium extruded profiles, and they're just better tops. But again, I'll need 2 lefts and 2 rights and have to cut and weld those up. So that's what's going to happen with the doors. Factory seat base, obviously new floors and tunnel. Very basic forming stuff there. You know, that'll be my first go at body work. So I'm not do any of this for a living. I'm a carpenter in construction and supervisor in construction. So this is just for me, for myself. So I'll figure all that out and do all that as well. Nothing changes as far as the bulkhead, you know, all the crucial pedal mounting, safety aspects with brakes and clutches and steering columns. That's all factory, which is really nice. And I've sat in it and set up the seating location, and the ergonomics are still fine, like really good to be honest. So that should work quite nicely. So the front, as far as the suspension goes, yes, those radius arms are longer. I made those as well. So we've got the new radius arm mount here, which again was bought as a factory mount, cut and shunt. So this is the factory mount that I cut and adapted, brand new one, to suit my location, my angles and everything. And as the chassis rail gets deeper, it didn't just slot over. Plus I've added this doubler here again, so you can see there to there to strengthen that section of chassis for that. So we've tied crucially into the top flange for our longitudinal loads, and the bottom ties up under, again into my doubler, which is nice and long. So we've got really good attachment there. One of the key things with the radius arm mounts was there's bracing. So if we just sneak in here a little bit more, and I'm sitting on my butt, so bear with me. That's actually the original mount there. So we've got some triangulation gusset from the chassis to the bulkhead outrigger mount and to the radius arm mount. There was also welded here, going up under the bulkhead mount, an angle, like a formed angle. So it wasn't boxed in or anything, it was literally an angle, and that came back and tied that in. And that tied in crucially from this point, it was welded in around this bush, the steel bush for the mount, to there. Now obviously mine's at a different angle, it's a lot longer. I started just to go down that path again, let's try and keep things a bit factory where they work. It was just going to be a massive ground anchor. It just was not a good design for my application. So the tube will transmit the loads really, really well. And then I have laminated it here where it might see impact, you know, adding strength where we need it, not where we don't, which again is a bit of a Land Rover theme, which is a good thing in a way. We've welded that to the mount and then gusseted it here for that bracing and transferring. And then here we've slit it and installed a plate and welded it in. And then that transfers right up here under this mount here. So we've got that really, really good bracing for the mount and for the outrigger mount. And what I did here was left this bottom part of the angle as a flange to help this triangular mount, this gusset, which I feel is still very important for the front outrigger, which is the bulkhead mount. Like we don't, you know, any frontal impact, corner impact here, these things would just peel off and fold backwards without these gussets. And the reason I left the remnants of the original radius arm mount is that just stops in the middle of nowhere in the web. Now the web, because they're so deep, the web's got some stiffness up near this corner where you know, imagine that 30 mil, and same on the bottom. But as you get into the middle, it's quite flexible. And with the load path coming down here, I figured I'm going to put a little flange, like 20 mil flange on this, because it'll stiffen up the load path. We want to transmit that longitudinal force bang into that, into our top web. That, you know, and it just meant less cutting around and potentially wrecking things and putting nicks and cuts in the chassis, which it's a stress member. It's not, you know, surface finish and those imperfections all do count to a degree. So we want to reduce the risk of problems. So that's left. Everything's the same on the other side. This intermediate cross member, which trying to think, it sort of had some brackets on it that then went forward, and they didn't pick up the rear tub. I think a lot of people think they probably pick up the rear tub. What they do is they're set up in a way that I think they stop acceleration forces and most importantly braking. They're not bolted to each other, but they're set up in a way that it can't push forward. It's not a load up and down, it's a forward force. This cross member may have to go. I'm doing an engine swap. I'm not a fan of the TDIs. TD5 is a good engine, but it's undersized capacity-wise in my opinion. Land Rover love them, but man, their engines, they're just gutless and or unreliable in the scheme of things. So at this stage it'll be BMW M57 with a BMW ZF 6-speed manual gearbox, LT230, and whether or not, because I'm going to move that engine as far back as reasonably possible. Prop shafts, I don't mind getting factory custom prop shafts made. I'm going to get heavy duty prop shafts made anyway. And making the front prop shaft longer is only a good thing for its angles and its uni angles, but also in relation to the radius arm length. If you look at the factory stuff, the prop shaft is similar to the radius arms, which means they're both moving up and down in the same plane. So, if I can move the whole transfer case back, say 4 inches maybe, and all that back 4 inches, beauty, better weight distribution, better clearance at the front for the radiator cooling package, which is going to be a big deal. In Defenders, it's not great, and we've got more heat, more output, energy output. So that's sort of what's planned in for there. The radius arms I fabricated from scratch, and they do have a little bit of caster correction in them for what I wanted, and they're basically a box section, so top and bottom flanges 30 by 12 from memory, and the webs, so that's bottom top flange, they're continuous, they're not cut and shunt. That was forged, I've hand forged the bottom with oxy to suit the radius and the curves. The sides are 4mm, but then 4mm laminated, and again it's box section, so they're pushed right out. The thing here in Australia with modifications, we're a bit limited, not as limited as some places in Europe, but certainly not as freedom as far as modifications as in America. And there's also scrutiny to the quality of the work. So state to state, they're fairly similar, the codes and what you can and can't do. And then so some things you just can't do. Doesn't matter how well you would do them, they're just not allowed to do it. End of story. So we work within what we are allowed to do, and then it's a matter of how we're going to go about and achieve that from an engineering structurally sound, and then performance of fit and finish and quality of workmanship. So for example, all my suspension links had to be, because with the engineer that I'm working with, he doesn't know me from Adam or Barry or Bruce, and he's like, hey mate, we get all your suspension links, we get the welds x-ray tested, so the trailing arms, the A-fray arms, etc. had to be x-ray tested for the weld quality, and then the chassis work is all visual inspection, and so he comes and looks at it. There's certain things like the rear cross member, certain distances past the rear axle, it's sort of a bit freer, so to speak. It's still got to be done right. But crucial things are braking, steering, suspension components, and that structural section of the chassis where all those things are tying in. So, and we're limited to what engines and capacities we can swap in and stuff like that. So and emissions as well. So it is what it is. I don't mind it. It makes it a bit more challenging for sure, but it also makes it a really good learning curve. And it challenges and pushes me to do things better, which I actually enjoy. Like I said, it gets frustrating, but it's a better outcome. And the one thing is that with this sort of, it's not policing absolutely, but with this sort of regulation and control, it's avoiding having absolute junk on the roads. Now there is still, there's still some pretty dodgy stuff getting out there, and some people don't get their stuff engineered at all, and they run the gauntlet. And some people do with a bit of a dodgy, catchy, whatever, but they're not interested in that. At the end of the day, this is going to be 100% registered, insured, road legal, certified. Everything that needs to be done, has got to be done, is getting done. By a reputable engineer here where I live, and you go away on a holiday, you're doing thousands of kilometres travelling. If you get pulled over and defected, it's not a matter of you drive home and then you go and sort your car out. You can't drive, so how are you getting your car home? How are you sorting it out? So, I'm doing this as per what's required to do it right, and then I don't have the stress. So. That's my choice. Each their own, man. Like, it's just, you take responsibility for your own actions is the biggest thing, and don't sort of blame everyone else because it should be allowed but it isn't. Whatever. So, got a good Parenti bulkhead, stripped it, hot dip galvanised. I'm never going to want to replace another one of these. That's not a good job. That's not a fun job. No one wants to do that. So hopefully, we won't see any rust before I'm ready to roll into the ground and not have to worry about any of this ever again. So this little blue bracket here is simply some RHS, or rectangle hose section, that I've cut the top off and used because it's a perfect size to pick up both sides. There we go, both sides of the bulkhead, and that's my rock slider or structural sill, outer sill if you want to call it, a rock slider mount. There'll be a flat plate welded on here down to this, so it can't just act as a hinge, and it's not just focusing on those 2 points. Sorry guys. That's the front pickup. I might do a bit of flat bar here as well, just so, but it's just a pivot point, so yeah, got a bit of thought on that, but that's just to work in and make it not just a single flat bar that some people do, and then they can really just lean, it can be a bit of a problem. Then the rear picks up off the rear bulkhead outrigger, or rear tub outrigger, and again, this was a factory outrigger. They don't look like this. They're not boxed in. They're not shaped like this. Well, my trailing arm comes up through here now, so it's normally the trailing arm's here. It doesn't come past it. So this is clearance. This gusset, because we're trying to, body weight is mostly on here, pushing down. So we're tying that corner back down, and then the boxing in the bottom, the underside is, the rock slider wants to rip it up off the bottom. So flared holes for drainage, and then more drainage here, and then those flanges tie in under the bottom flange of the chassis rail, and then I've overlaid 3mm to strengthen the top, knowing that I was going to do something stronger up here. So there was a big, again, because these are factory, and the engineer likes that too, because they're factory parts proven by the factory for replacement parts for like rust, lots of rust in Europe and the UK, so all these components are available. He doesn't have to worry about the design of that because it's Land Rover design. So that's another reason. A lot of this stuff could be fabricated, but again, like, it's when you've got forming C sections and you've got really deep toes and narrow flanges, that's specialty tooling I don't have. So just a little bit of plate, because there was some few holes peppered here right near this bottom edge where the load path is. That's just to stiffen and avoid those holes. Those holes were just there because they're factory. So crush tubes in these for my slider bolts. You might have thought, well, why isn't the bottom one down there? Because it's pulling in the bottom. This was going to be the battery tray, and having the mount down there through the tray wasn't going to work. So it's strong enough to do what it is based around that, so that's where it is now. It's got a big gusset, or a couple of gussets inside it internally, as they have factory, so that's well and truly strong enough there to do the job. I've also got a cap in the tops of these, which I've started to form some plate in, just again to stop that lateral sort of flexing. So this little bracket will drop on the ground like that, and drive away, you beauty. How many times am I going to drop this? Oh, butterfingers. Anyway, it's something like that. It's because it's a corner weld that it's literally designed to be to the millimetre sort of thing in between it. But yeah, that'll just tie across there and fix all that up and give us some lateral stability. It also gives me somewhere to land the tub mount, that's or one end of the tub mount. And it's helped tie that for the A-frame, which is pretty crucial lateral, because the A-frame does all the lateral control of the rear axle. So just on the longer radius arms, we've reduced that axle roll axis, which is oversteer, understeer. So basically, like a skateboard, if you lean on a skateboard, the wheels don't turn, but the trucks or the axles sort of pivot. If this is our skateboard, this crack running straight ahead here, and the trucks are perpendicular across it, or the axles are perpendicular across it, when you lean, they pivot. So now your wheels are pointing off in the direction, and when you lean one way, the rear pivots out there and the front pivots out there, and you turn, so that's oversteer as far as suspension geometry and solid axles go. So the steeper the arm is, and the radius arm or the rear trailing arm or lower control arm for this certain example, the steeper they are, the worse your oversteer is. So ideally you want to keep it pretty neutral. The fronts are really quite, we're talking maybe 2 degrees. It's a bit deceiving here because the ground's out of level anyway. But the fronts are like 1 to 2 degrees, I think, axle roll axis, which is really good. And they're so long. See, the longer they are, the less you'll get of that steer, because they don't change geometry a hell of a lot in roll. And the rear, well, I've been able to put a bit of triangulation in them by putting the axle end further outboard than the chassis end, which helps reduce that angle as well as flattening them out. So the rear's got a little bit more. I like a little bit more personally in the rear than the front. We're steering the front around a corner. We've got good control, and the rear is going to follow because of having a little bit of oversteer. I don't like understeer in the solid axle four-wheel drive design. The vehicles understeer naturally. They want to go straight ahead. You've got all that mass trying to go straight ahead. You've got little traction and little tyres in the scheme of things, and little contact patches, and you're trying to change the direction of all that mass. So having a little bit of oversteer, and it's not crazy, it's only, I think it's 4 degrees, and they're long arms. Like factory at 2 to 3 inch lift, you've got 12 degrees and a short arm. So much improved there. So that's the idea, and plus better driving forces through the chassis instead of up, not jacking. We're pulling on the front, it's pulling, and the rear it's pushing forward. So that's really sort of crucial as far as my thought process is. Moving around to the front, no engine, that's got to go in. New engine mounts obviously, and some work to do there, a bit of reinforcing. Axle wise, Rover axles front and rear, as in Rover diffs, and modified strengthened housings that I've done myself. And the other thing I've done is, it might not be obvious here, but they're factory rims, they're not modified, and we've got a nice wide track. I've made the housings wider, so we're not loading up any of the steering components. We're not changing the steering geometry. We're not overloading the wheel bearings or the stub axles. 75 millimeters per side of graded track. Yes, it means custom axle shafts, but you do it right, you do it once. So factory 130 rims is what I'm going to run. Wolf rims in this case, basically tubeless Land Rover factory rims, heavy duty, good offset, everything's good about them. I like them and I like the look. I'm going for a really factory look in a lot of ways here. So the front housing's been widened. In this case I went with, originally I was just going to bolt these, I machined up these spaces so they bolt to the original end flange, which is friction welded on, as per all the early ones up until the last of the Defenders, where they made a mistake and changed to MIG welding and they failed, or some did. This is 4140, and then we've got our new swivel ball flange here. There was a bit of concern speaking to a mate who's much more knowledgeable than I am, because I'd had some sort of real world experience where this wasn't going to be a problem just bolting them up with the 7-bolt flanges. But, there was concern because we've changed the ratio for the moment, bending moment, given the distance that we've increased further outward from this joint. This is still a joint, but this is our key structural joint, really, under this circumstance. So these have been welded, continuous welded all the way around. Everything's TIG welded that I'm doing. And this was quite a process because we had to preheat, special filler, preheat, and 2 passes, and you preheat. You have to get it to the right temperature, not too hot, not too cold. It's a bit Goldilocks, got to be just right. And then the interpass, so you weld, then you have to wait. It gets hot, you got to wait till it cools to the right temperature. Make sure it's clean, do another pass, and then we'll have to immediately stress relieve it, which is increasing the temperature to a certain amount for a certain amount of time. And both sides were done to maintain the integrity of the 4140. So that was a bit of a mission, but we got there in the end. So they'll be more than sound. And this housing is reinforced externally from the radius arm inwards, but internally from the original flange in past to where my finger is here. So that will help at this point with the extra load that's on this point. But there's bolt-on portals which are wider, 10 mil wider, and with an offset leverage which is greater than what I'm going to put on them. And these housings that haven't been laminated or strengthened have not failed. So plenty of confidence in that. The rear didn't have to do that. The rear housing is widened, in all the fabrication and everything. So that square block in there is for the Maxi Drive diff lock actuator cylinder. So I'm running Maxi Drives front and rear, and Maxi Drive shafts. Yeah, that's just what I'm happy with, what I like, and have always sort of stuck with Mal's stuff. Even though he's retired, still support the product. So that's a fair overview of the vehicle. A little sort of quick note on why custom and why K110. So being in construction, my business name was Custom with a K because I figured there was nothing more custom than changing the word and the lettering. And the K110 is a homage or a paid tribute to Mal's story. He's still with us, thank God. But Mal is the original owner and creator and main man behind Maxi Drive, and top bloke, heavily involved in the Land Rover community in Australia, but also through his products throughout the world. It wasn't originally called Maxi Drive Engineering. Originally his business was Key 4-wheel drive. Might have even been Key Industries originally, and then Key 4-wheel drive. Maxi Drive was the name he gave to the diff locks that he designed, his diff locks, because Maximum Drive, Maxi Drive. It was down the track where he was making more and more and more components, and he sort of retired out of mechanical repairs and fixings of servicing of Land Rovers and just focused on his great range of heavy duty components and designs and stuff, that he called it Maxi Drive Engineering. So it was Key 4-wheel drive, and he actually built some 118-inch wheelbase chassis where you would drive in your Series 3, and generally they were the Utes, the 109 cab chassis Utes, and you would drive out on a 118-inch coil sprung chassis. And he called those chassis K118, K for Key 4-wheel drive, and 118 for the 118-inch wheelbase. And so, I'm custom for my work, and then K110. So K110 is what I call my vehicle. It's, it might be a bit funny to some people, but, spent a bit of time with Mal. Was fortunate to see how he did things in his workshop and annoy the hell out of him with a bazillion questions, and, always had the time of day. Really, really, really knowledgeable, and very humble guy. Appreciate all the efforts and energies and ideas that he let me bounce off him over the years. And so, just a little bit of respect there for Mal. And, there's plenty of people that have been helping me with this build so far. The 109, he's a legend. Some of you may know of him. He he lets me use his lathe and bug him with, you know, machining questions, and we bounce ideas off each other, and he builds some pretty wild vehicles from his 109 on Volvo portals to his Jeep and stuff. He's a legend. And LS90, young lad that's was super generous with his time and help. You know, he's helped me out. Good old TDI Rick, or Rick 130, is a mate of mine, and you know, we're always bouncing ideas around. He's the oil guru and got a lot of road racing experience. You know, that he brings a lot to the table through there. And Isuzu Rover, he's another mate, and I'm always hassling him. He's an engineer and really switched on, and lots of chemistry questions for him when I'm having troubles with things, and you know, with things that are sort of involved with the build and other ideas. And you know, he's a legend. Bill, who's gone by Daddy Longlegs and Portal Rover, and you know, he is a dead set legend of the game here in Australia, and you know, is sort of known around the world. And he's built and fabricated some things in his backyard that just blow your mind. You know, his own portals from scratch and from Land Rover parts, and you know, wild suspension ideas and 6-wheel drives, and you know, bounce ideas off Bill. And again, you know, have good long conversations with him on the phone. He just, you know, very generous with his time. And lastly, but certainly not least, and you know, to me most importantly through the last few years, is Bush 65. He blows me away with what he's sort of done time-wise, and the, you know, the effort he makes in breaking things down and explaining them. You know, I have a bit of an idea of what I want to achieve, and I come up with a bit of a design and thought process, and you know, run it by him, and oh man, it's just crazy. So you know, there's plenty of other people. You know, Rick from Kingpin, he's always super helpful, and I get bits and pieces from Rick, and he's swallowing my swivel balls, you know, at the moment. And I'm sure I've bought other things from Rick, and I'm actually considering he's got a big brake kit in development, so that's looking very promising. You know, so there's plenty of people. There's always people involved that you don't see or don't hear from, but they definitely make a difference to the build on where I'm at. You know, I try and be self-reliant and do everything myself, like, you know, apart from some of the welding on the vehicle, which started off with a guy, like a paid welder, which was a blessing in disguise when he was excellent welder, but got a bit messed around time-wise and stuff, and you know, the different priorities and stuff, that's fine. But it made me jump in and really hone my skills. So that's been, again, a blessing in disguise. So I just try and achieve everything that I possibly can myself, you know, and, you know, don't want to be too reliant on other people, but sometimes you've got to ask for a bit of help. And, you know, hopefully you got people that can help out when you need, and, you know, you help them when they need it. So, yep, anyway, that's where it's at. It's been a long amount of time to get to this stage, which it's still not even rolling chassis, so to speak, but I've got all the arms made and everything. The rear housing's out at the moment because I'm doing all this chassis work, and lying on your back with that in the way, it's just a real bear, so to speak. So I'll just do a few more things with this clean and clear, and I'm focusing on load supports, chassis work through here, and then probably making the tub, or starting to make the tub, which will be time consuming. The idea is to leave the engine until sort of not last, but latest, because I've got a running engine and I don't want to have it sitting in the vehicle for years, which it will be if I do it now, you know, corroding and having issues as these things. I'm using the vehicle, so hey, Rolling Stone gathers no moss, servicing it and running it and making sure it works. So that's the idea. So it will, you know, this is going to be as long, already has been a long slow process. So it's just a matter of chip away at it where and when I can. But yeah, thanks for watching if you have, and you know, got any questions, shoot them down in the comments. Got any comments, feel free, good or bad, you know, it's all good. And hopefully that was of some interest to someone that, you know, a modified 110. Cheers.